Logarithmic function. Logarithmic function, when we talk about the function, that means we are talking about an expression includes x and y, which means y equal log x with the base like 2 or 3 or 4. And since we're talking about function, instead of y, we use f of x. So this is a logarithmic function. And when we want to graph these types of function, you always replace numbers for x and find y. But you know the y values are always powers of 2. For example, if you replace the x by 0, that means you are trying to find a power of 2 which is equal to 0. Are we able to find a power of 2 that makes it equal to 0? Because any powers of 2 should be a number more than 1, because 2 to the 0 power, which is the smallest number, is 1. Or even if you replace the x by negative number, you will get a fraction. There is no way that you multiply 2 by itself and you get a 0. So it means that the x cannot be 0. Okay. If I replace x by 1, that means I'm looking for a number for y, which 2 to that power is 1. And the answer for y is 0. When you replace x by 2, that means you're asking 2 to what power is 2, which is 1. And as you see, all of the y values are also positive numbers, 0, 1, 2. Are we able to replace negative number for x? For example, can I replace x by negative 1? Let's see what happens. If I replace x by negative 1, that means I'm trying to find a power of 2, which is equal to negative 1. There's no way we get a negative from a positive number. So when you are finding a powers of 2, then multiply 2 by itself. And when you multiply positive numbers, because the base must always be positive in log function, and when you multiply positive functions by itself, no way we can get a negative number. So x cannot accept any negative number. That means this number, whatever is inside the log, must always be a positive number. Okay. And that helps me to find the domain, because domain is all values that I am able to replace for x. So every time they ask me to find the domain, that means tell me what numbers I can replace for x. For that place, I am only replacing a number that makes it positive, not 0, not negative. So to find the domain of the function, the argument or that place must always be positive. So how do we find the domain? If they ask you to find the domain in example 5, you say whatever is inside the log must always be positive. What does it mean? X minus 3 must be positive. That means it must be greater than 0, because positive numbers are all greater than 0. And then isolate the x by adding 3 to the both sides. So you say that x must be greater than 3. You are able to only replace numbers for x that are greater than 3. And if you show it on the number line, from negative infinity, if 3 is here, you're only able to replace numbers that are greater than 3. You are not even able to replace 3, because 3 makes it 0, and we cannot have 0 at that place. So the domain is all numbers starting from 3 going to infinity, not including 3. So that is the domain of the function. Do I care about positive 2? No. Positive 2 is just a shift. So we learn about that when we learn about shifting, horizontal shift and vertical shift, when we talked about in that video that we talked about transformations of function. So when we have a function, if you see an x is adding or subtracting by a number, that means that's a horizontal shift. If you see the whole function is adding or subtracting by a number, that means that's a vertical shift. So this function, it's actually the same function that we had it here, but it's shifted 3 to the right and 1 up. But we know that logarithmic functions, they also have a vertical asymptote. We talked about the asymptote in exponential function, and we said that all exponential functions have a horizontal asymptote. And the horizontal asymptote in general is x-axis, and we have exponential function. Since logarithmic functions are inverse of exponential function, so now for logarithmic function, when we graph them, you see that we will have a vertical shift, vertical asymptote, which is the straight vertical line. And how do we find that vertical asymptote? By just finding what number when you're finding a domain, whatever number that you get here, that is the exact vertical asymptote. But since vertical asymptote, it's a straight vertical line, and all of the straight vertical lines are always x equals something. X equal what? X equal 3. Because x equal 3 in this function, if you replace the x by 3, you see that the argument 3 minus 3 gives you 0. And that is exactly where the asymptote is. So if you set it equal to 0, that is the asymptote. And don't forget, when you're writing domain, you have to show the interval notation. But when you're writing about the equation of the asymptote, you have to write an equation, x equals something or y equals something, which makes it an equation. Don't just leave a number. Just leave a number and say, okay, asymptote is 3. No, asymptote is a line. Line needs an equation. Equation means x equal a number or y equal a number. Let's look at example B, part B. First, you want to find the domain. We say whatever is inside the log must be positive. Because if it's equal to 0, that's asymptote. If it's positive greater than 0, gives you a domain. So if you solve this one and isolate the x equal negative 1/2, that's your vertical asymptote. And if you isolate the x greater than negative 1/2, it's the domain. But we always like to write the domain as an interval notation. And interval notation starts from negative 1/2 going all the way to positive infinity, because we only need greater numbers. Okay, now after learning how to find the domain and how to find the vertical asymptote, we can start graphing them. So to graph logarithmic function, we need to create a table of value again. But what value we can replace for x? After finding the domain, we will figure out. So the first step is finding the domain, because we need to know what number I can replace for x. After finding a domain and find a vertical asymptote, we need to create a table of value. But we only choose the x value that are in the domain. If domain is x greater than 3, you only choose the numbers that are greater than 3 to replace for x. But you only choose those that gives you a nice whole number, not fraction, not decimal, okay? Fraction is okay, but not decimal. And then after graphing the vertical asymptote and plotting the point, we can connect and graph the function. Let's look at this example. We want to graph this function. First, we need to find the domain. To find the domain, we need to look at the argument, which is x minus 1. We said x minus 1 must be positive to find the domain. Isolate the x by adding 1 means that domain is all x values that are greater than 1. That means from 1 to infinity. That's the domain. If you set it equal to 0, gives you the vertical asymptote. So that's the equation of the vertical asymptote. Now we need to create a table value and replace numbers for x and find the y. But what number we can replace for x? Only numbers that are greater than 1, because it's a domain. It's in the domain. We don't replace 1 because 1 is the asymptote. X equal 1 is the asymptote. Let me graph the asymptote first. Straight vertical line. Only numbers that are greater than 1, like 2 or 3 or 4 or 5 or 6, but we choose those that gives us a nice whole number. Let's replace them and see which one gives us a nice number. Because the base of this log is 2. And only numbers that are powers of 2 gives you the nice number. Then, okay, if I replace 2, I will have log of 2 minus 1 base 2. 2 minus 1 is just 1. And we say, what's the log of 1 base 2? Log of 1 base 2 means what power of 2 gives you 1? And the answer is 0. Because only 2 to the 0 power is 1. But after that, we also have plus 3, and 0 plus 3 is 3. Okay, I can take that. It's a good number. Let's replace 3. If I replace the x by 3, 3 minus 1 is 2. And we say, what's the log of 2 base 2? Log base 2 of 2 means what power of 2 is 2? Or 2 to what power is 2? Just 1. The answer is 1. And 1 plus 3 gives me 4. Okay, it's a good number. I can choose that. Let's replace 4. If I replace x by 4, 4 minus 1 is 3. What is the log of 3 base 2 or log base 2 of 3? What power of 2 gives us 3? We don't know. Only calculator knows. So no, we don't choose 4. Let's replace 5. 5 minus 1 is 4. What is the log base 2 of 4? Or 2 to what power is 4? 2 to the second power is 4. That's right. And after that, we have a plus 3, and 2 plus 3 gives me 5. And I think that's enough. We don't need more numbers. Every time you get at least 3 numbers, you can stop and graph the function. Now let's find the points. 2 and 3, 3 and 4, and 5 and 5. We need to connect them. You said that the domain is from 1 to infinity, which means your graph also must start from 1 and going to positive infinity. So starting from 1 going to positive infinity, but on this side, you know that we never cross the vertical asymptote. You get very close to this line, but not cross or touch this line. And this is the graph of a logarithmic function. So only choose the numbers that you can replace for x. Only choose the numbers that are in the domain and gives you a nice whole number for y.